Hello everyone, welcome back to our channel. In today's video, we are going to look at one project on univariate time series forecasting using time series models which are ARIMA and SARIMAX. So let us look at the problem statement. We are trying to forecast the sales for a grocery store for the next 12 months. So let us see the data set that I am using over here. So this is the data set. They are having two columns, date and the sales, and the dates are starting from the year 2021. This is the monthly sales data for that grocery store, and we have the data till 2025 March. Okay, so for the next 12 months onward, we are trying to focus the sales. So what I have done is I have loaded the same file in my Google Collaboratory, and then we'll start with the project. Okay, so as a first step, what I have done is I have imported the required libraries, pandas and matplotlib. Then I have loaded the same data that I have uploaded over here, grocery store sales data, which is present in the CSV format. That's why I have used the read CSV function of the pandas. Okay. Then I have stored the data and I have explicitly mentioned that to consider the date column as a date type and not of the object data type. Then I have given the index column as a date so that our data frame will have only a single column called as the sales. Okay, as we are performing univariate time series forecasting. Now I have dropped any null values that are present in the data set. Then to check the how many number of rows that we are having and how many number of columns we are having, I have used this shape attribute on our data frame. Now, once you do that, you will be able to see that there are 51 rows, that is 51 records are present, and the one column is there present, which is of sales. Now let us look at the first few rows of the data. You can do that with the help of head function. So head function will return the top 5 rows by default. So the data is starting from year 2021. Okay. Now let us see the last few rows of the data. You can do that with the help of a tell function. So with the help of tell function, you will see the last 5 rows of the data. So the data is present till 2025 and March, right? Now let's see how can we check the stationarity of the series, because the stationarity is the main assumption in time series. Okay, so what we'll do is we'll try to plot the grocery store sales over the years. Okay, with the help of this line chart, you can see that there is uptrend present over here. What does the uptrend means? The values are continuously increasing, that is the sales values that are present on the y-axis, they are continuously increasing over the years, right? So that means the uptrend is present over here, and you can see that the seasonality is also present. Why? Because this same repetitive pattern is appearing over the fixed period of time. That's why seasonality is present. But can you see this series is a stationary one? No, this series is not stationary. Why so? Because the mean and variance both are not constant with respect to the time. That's why this series is not a stationary. So, how can you make your series a stationary? So, to make your series a stationary, you have to use a differencing technique. So, what is that technique? In which you will be using this diff function on your data frame and will store it into another data frame. And let's try to remove any null values that are present, and let's try to plot the values the having over the years and the month that we are having. So over here, can you see that is this series a stationary now? Yes, because the mean is constant with respect to the time and the variance is also constant with respect to the time. So this series has become stationary after taking differencing for the first time. Okay. Now there are various time series models are available. In this video, we will be focusing on the two. They are ARIMA and SARIMAX. So what does the ARIMA and SARIMAX stands for? So ARIMA means autoregressive integrated and moving average, whereas the SARIMAX means seasonal autoregressive integrated moving average with exogenous variables. So exogenous means having some external factors. Okay. So what is the autoregressive means? Autoregressive model is a one-time series model in which you are trying to focus the values based on its own past values. That is, the model will try to regress its own past values. Then integrated means the number of times you have used the differencing technique to make your series stationary. We have seen that we have differenced our series for the first time. That means the value for D will be 1. Okay. Then MA is nothing but moving average. So what does the moving average time series model is? So this time series model will try to forecast the future values based on the past errors. Okay. So I hope you are familiar now with the AR, I and MA. Now, this AR part will help us to find the value for P. This I part will help us to find the value for D. And this MA part will help us to find the value for Q. So you have found the correlation between this AR, I and MA and their correlation with this ARIMA and SARIMAX, how they are related with that. Now, how you can find the values of PD and Q, that is AR part, I part and MA part. So we have already seen the value of D. We have found the value for D by using the differencing technique, and to find the values of the AR part and MA part, that is to find the values of P and Q, you will be using two plots. Okay, they are called as PACF and ACF. Okay, so what PACF is? PACF is partial autocorrelation graph and ACF is autocorrelation graph. Okay, so with the help of these plots you will be able to find out the values of P and Q, because these values, the finding the values of these all three is very important, as it is important in this models ARIMA and SARIMAX. Okay, based on these values only you will be building these two models, right? Now, how you can find the values of P and Q? For that, you have to import plot ACF and plot PACF functions from this stats models library. Now, what we'll do is we'll try to create a subplot which is having a one row and the two columns, and in that subplot we'll pass our cells series to this particular functions. Okay, plot ACF and plot PACF. Now this plot PACF function will help us to find the value for P, and this plot ACF function will help us to find the value for Q. Okay, now let's see, in the first subplot I have plotted the PACF graph, and in the second subplot I have plotted ACF graph. Okay, so here in the both graphs you will be able to see this shaded area. So this blue area, it means it is an insignificant area, and same over here, right? So whatever these vertical lines are called as the lags. Okay, so if the lags are above that particular insignificant area, that means that it is correlated. Okay, means this value will be helpful in finding the future values. Okay, so from this graph we can find out the value for P as 1. From this graph we can find the value for Q as 1. Okay, you can consider the value for Q as a 2 also, right? But you cannot consider the value for 3. Value for Q as 3, because it is crossing this particular insignificant area. So these first two lags are significant, and over here only the first lag is significant. So up till now we have find the values of P, D, Q, and all they are 1. And we have already found the value for D as 1. Why? Because we have differenced our series, right, for the first time to make it stationary. Okay. Now, what we'll try to do is we'll try to build the ARIMA model now. But before that, we'll split our data set into two parts. Why so? Because what we'll do is we'll try to build our model on the training data, and on the testing data, we will test our model. Okay. And then we can compare the actual values of the testing data that we are having and the predicted values by our ARIMA model. Okay. So that's why we are doing the split over here. Now what I have done is I have stored the last 12 records into my testing data and the remaining all records in my training data. Okay. Now let's try to build a ARIMA model on our training data. Okay. So training data is it is stored into this train DF. Okay. Now for that you have to first import a ARIMA class from the stats models library. Okay. Then what you can do is you can create an instance of that ARIMA class and store it into this model ARIMA. Focus over here, in this particular class we have given our training data along with the order. So what is this order? Is the values of the PD and Q. Okay, that is the values of the AR part, I part and MA part. Okay, now we will try to build our ARIMA model based on this instance. So how can you build the model? You have to just use the fit function. Okay, now let's try to see the summary. This summary will help us to have the closer look at the statistical values that are present over here. Now you can see that these are the results given by the summary function. So the dependent variable is the cells variable on which we have built our model. Then this is the model that used, that is ARIMA 111. Then here you can see that these are some statistical values of coefficients, standard errors, the z value and the p values. Okay. So what is here written? AR L1 and MA L1. So AR means autoregressive and L1 means the first lag. MA means moving average and L1 means the first lag. So as we have built this ARIMA model on with the parameters as a 111, so it is dependent on its previous lag of the AR part also and the MA part also. So this is the result that we have got from this ARIMA model. Okay. Now let's try to forecast the cells for the next 12 months. Okay. So what I have done is I have stored the value as a 12 inside here in the n forecast variable. Then we'll try to use this predict function. And here I will give the starting point and the ending point. Okay. So we'll start from the ending of our training data plus the next 12 months. Okay. So as we are trying to do the predictions for the testing data, right? Now we'll try to rename the column for the clarity purpose, and you can see that these are the predicted values given by our ARIMA model, and these are the values given for our testing data, not for the future values that we are trying to predict, right? Now let's try to see this in the data frame. Okay, so I have created a new data frame called as a preddf. Inside that I have stored this predict series because it is a series. Okay, this is the series. Now I have converted into a data frame, and now I have rounded these decimal places to 0. Okay, so that we can have a closer look at this particular actual cells values that are predicted. Okay, by our ARIMA model. Now we are already having the actual test data with us and the predicted values that are given by the ARIMA model. Let's try to concat all those values into a single data frame, and let's try to see the results. Okay, what we are getting. So here what you can see over here is these are the given on the given date. This is the actual test data that we were having, or the actual cells that we were having, and this is the values of the predicted cells given by our ARIMA model. And this error column I have given so that you can understand the difference between this actual and the predicted cells values. Okay, so you can see for each and every record present over here the difference is much higher, right? That is, the error is so high. So what we'll do is we'll try to see this actual and the predicted cells visually. Okay, so for that what I have done is I have plotted these two series separately, and we'll try to see the results now. Okay, so you can see that this is the chart that we are having. On the x-axis we are having the month and year, and it is starting from the April 2024 and it is ending till the March 2025. Okay, and on the y-axis we are having the cells. So this blue line indicate these are the actual values of the cells, that is the actual testing data that we were given, and this red line is indicating these are the predicted values of the cells. So here if you can see carefully, our ARIMA model has not predicted the values correctly. It has understood the trend, that is the upward trend is present, it have understood that, but it has not captured the seasonality. Okay, and ARIMA model cannot handle the seasonality, and that's why we are using SARIMAX model. Okay, so what we'll do is we'll first use this auto ARIMA function. Auto ARIMA function will help us to find out the best possible values of the non-seasonal and the seasonal order. But before that, when you try to import that AutoArima function from this PMD Arima library, you might be facing some of the errors. So for that, you have to reinstall some of the packages. So this is the some of the code that I have written over here. Okay. So what you can do is you can use this AutoArima function from this PMD Arima library, and this AutoArima function will help us to find out the values of non-seasonal and the seasonal order. So what is that is? Non-seasonal order means the values of PDQ, small PDQ, and the seasonal order means the values of capital P, D and Q, and the value for which we are trying to predict the cells. Okay, that is the seasonal period. We have already seen that our data is having some seasonality. Okay, so that's why we will be using this SARIMAX model, and this AutoRima function is the best function that will help us to give the values of the PDQ, that is the non-seasonal order also and the seasonal order also. So for that I have given our training data to this ARIMA function. I have explicitly mentioned that seasonal is equals to true, and I have given the forecast period for which we are trying to forecast. Okay, so m is equals to 12 means for the next 12 months we are trying to forecast the sales for the grocery store. Now I will save this into this ARIMA result and let's try to see the summary. So if you observe over here, the model that is used over here is a SARIMAX, and this is the value for the non-seasonal order and this is the value for the seasonal order. Okay, so this 0 stands for the value for small p, this is the value of small d, and this is the value of small q. 1, this is the value for capital P, this is the value of capital D, and this is the value for capital Q. And this is the seasonal period for which we are trying to forecast the sales. Okay, and here you can see that this is AR.S means autoregressive seasonal lag number 12. MAS means moving average seasonal lag number 12. So that this model is dependent on the past lags, 12th number lags. Okay, and these lags are seasonal lags. Okay, and these are the values of the corresponding coefficients, standard errors, the z value and this p value. So this z value is calculated by dividing this coefficient by the standard error. Okay, and this is the p value. So these are the summary that we have got from our ARIMA function. Now what we'll try to see that this seasonal and non-seasonal order, we can access it by using this order attribute and the seasonal order attribute over this variable on which we have call that function. Okay, ARIMA result, we have saved that function inside over here. So what we'll do is we'll try to call this order attribute and the seasonal order attribute to see the actual values of the non-seasonal and the seasonal order. Now we have already got the values of this. So what we'll do is we'll try to build our SARIMAX model, and this SARIMAX model will require this non-seasonal as well as the seasonal order, and that's why we have used ARIMA function. Okay. Now what we'll do is we'll import this SARIMAX class from this stats models library first, then we'll provide this training data to our SARIMAX class, we'll provide this non-seasonal as well as the seasonal order to it, and let's try to build our model on this particular SARIMAX. Okay, so we'll store that model into this model fit variable and we'll try to see the predictions. Okay, so here I have used the same code, like you can use the predict function. You can give the values of the starting point and the ending point as we are trying to see the result for the testing data. So I have given the values for that in the starting point and the ending point. Okay, then we are trying to predict the values for the testing data, right? So that's why I'm starting from the end of that our training data plus the 12 next 12 values to the ending data. Okay, now what we'll do is we'll rename the columns for the clarity purpose, and we'll store this particular series into a data frame, and we'll see the predictions. Okay, for the next 12 date for the next 12 records that are testing records. Okay, now what we'll do is we'll try to see the actual and the predicted results just like we have done for the ARIMA model. Now we'll concat this actual testing data that we were having and the predicted values for the testing data, and we'll see the error. Okay, and I have renamed the columns again for the clarity purpose. So here you can see that on the given date these were actual cells and these were the predicted cells by our SARIMAX model. Okay, and these are the corresponding value for the error. You can see that this error is not that high, but let's try to see this series visually so that you will be able to understand. Okay, so what I will do is I will try to plot this actual and the predicted cells. Okay, and here you can see that this blue line is the actual cells and this red line is the predicted values of the cells. Okay, so you can see that our SARIMAX model has captured this particular pattern. Okay, the values are close to each other, they are not exactly accurate but they are close. So SARIMAX model has given the decent predictions. Okay, so we have tried that SARIMAX model on the training data. Now what we'll do is we'll try to build it on the entire data set. Okay, and then we'll try to see the predictions for the next 12 months. Okay, 2025 March onwards. So I have used the ARIMA function again so that we'll get the values for the non-seasonal and the seasonal order. So what I have done is I have provided the entire data frame to our ARIMA function, and the seasonal is equals to true means as our data is a seasonal and m is equals to 12 means the period for which we are trying to focus. Okay, it is in the months. So I've stored it into this AutoArima result function, and then what we'll do is we'll try to see the summary. Okay, so here summary, you can see that these are the values of the non-seasonal order and these are the values of the seasonal order. Okay, and these are the corresponding lags that are dependent. Okay, the corresponding values of the coefficients, standard errors, the z value and the p value. Okay, now what we'll do is whatever the value that AutoArima has given us, we'll try to give it as input to our SARIMAX class. Okay, so what I will do is I will pass an entire data frame to our SARIMAX, then we'll give the non-seasonal and the seasonal order to it, and let's try to build the model using fit function. Now let's see the predictions. So you can use the predict function. Now you can start from the whatever the number of records that we are having till the next 12 records. Okay, so we'll try to see the predictions. I have again renamed the columns and rounded down the values to the 0 decimal places. Okay, so this ARIMAX model has given the prediction for the next 12 months onward, like from 2025 April till 2026 March. So next 12 months data it has predicted. Now let us try to plot this actual and the predicted sales for that grocery store over the years. So this blue line is indicating these are the actual sales, and this red line is indicating these are the predicted sales, and on the x-axis you will be able to see the year, and on y-axis you will be able to see the sales values, right? So if you observe carefully over here, our SARIMAX model, when we trained it on our entire data frame, it has captured the seasonality, but which was not captured by the ARIMA model. Okay, so ARIMA model cannot handle the seasonality by default, and hence in most of the cases we will be using the SARIMAX model. So in this way you have to use the SARIMAX model to make the predictions or to do the forecast. Okay, and you can also change the forecasting period as per your requirement. So I hope you have found this video useful. So if you have found this video useful, don't forget to like, share and subscribe to our YouTube channel for more such updates. Thank you, and I will see you in the next one.